Okay, so here we're asked to choose the conservation of momentum equation at the left that matches the following situations on the right. And we're not going to use all of the equations. You'll notice we have 6 different situations and a lot more equations. So here we go. A rocket starts at rest. So we know since it's at rest, we're going to have a 0 before, and then it moves forward by shooting gases backwards. So the rocket moves forward, it's its own object with its own momentum, and the gases shoot backwards. The gases are its own object with its own momentum. So we have 2 objects with momentum afterwards. So we're looking for a 0 with 2 objects with momentum afterwards, which would be P. Alright, a rock at rest is thrown by someone. So give the equation for just the rock. So we're looking at this rock that's at rest. So we're looking for a 0 before, and then it's thrown by someone. So afterwards it's going to have a momentum. Now how do we get from 0 to having momentum? Well, we added an impulse. So we should have 0 plus impulse equals momentum, which is T. Alright, for C, 2 ice skaters bump into each other and grab on. So we have 2 ice skaters that are moving and they bump into each other. So we have momentum of the 2 skaters before, but then once they bump into each other, they grab on. So they become the momentum of the 2 objects combined. So we're looking for a situation where we have 2 before and 1 afterwards. So that would be S. We have 2 before and then the combined momentum afterwards. Alright, D. 2 carts hit each other and stop. So we're talking about 2 carts, 2 objects, that collide and stop. So stop implies that we have no momentum afterwards. We should have a 0 on the after side or the right side. And 2 objects with momentum before. So that would be 2 objects before and no momentum afterwards. That would be U. Okay, E. A car uses its brakes to slow down. Okay, note that it says slow down, not stop. Alright, so we're still going to have a momentum afterwards. We have a momentum for the moving car before, we have a momentum afterwards, but it does slow down, so a negative impulse was applied. So we're looking for momentum minus impulse and then momentum afterwards, which would be N. Okay, and then a person rolling on a skateboard catches a football. So we have a person and a football that were both moving before, and the person's rolling on the skateboard, the football's flying through the air, and then they become one object as soon as the person catches the football. So we're looking for a situation with 2 before and a combined momentum afterwards, which would be S again. Okay. For number 2, impulse equals force times time, and it's also equal to our change in momentum. Alright, so in our conservation of momentum equation, we have momentum before plus or minus impulse equals our momentum afterwards. Okay, so impulse is how we add or subtract momentum to a system, so our impulse is our change in momentum.